Good morning, students. Let us continue with Chapter 9, Force and Laws of Motion. In the seventh session today, we will do the example problems 9.6, 9.7 and 9.8 from the pages 124 to 126 of your NCERT textbook. Example 9.6. A bullet of mass 20 grams is horizontally fired with a velocity 150 meters per second from a pistol of mass 2 kg. What is the recoil velocity of the pistol? Solution. First of all, let us examine what are the values given here. Given here are the mass of bullet M1 equal to 20 grams. We know that 1 kg equal to 1000 grams. This 20 grams is converted into kg by dividing by 1000. So we get 20 by 1000 kg equal to 0.02 kgs. The mass of the pistol M2 is given by 2 kg. Initial velocities of the bullet U1 equal to 0 and of the pistol U2 is also 0. Here U1 and U2 are 0 because before firing both the bullet and the pistol are at rest. The final velocity of the bullet V1 equal to plus 150 meters per second. Here positive sign is taken because the bullet is moving from left to right in the forward direction. Let V be the recoil velocity of the pistol. Now here in the picture we can see two pistols. Figure A shows the pistol before firing and figure B shows the pistol after firing. Before firing, both the bullet and the pistol are at rest. That is the reason we took the initial velocities of both the bullet and the pistol U1 and U2 to be 0. But after firing, the bullet moves in the forward direction from left to right with a velocity of plus 150 meters per second. It is positive here as the direction is forward. At the same time, we can also observe that the pistol recoils in the backward direction. This shows that the velocity V must be a negative value. Now let us find out the total momenta of the pistol and bullet before the firing. That is, when the gun is at rest. Here we use the formula for momentum equal to mass into velocity. This is equal to 2 plus 0.02 kg into 0 meters per second. 2 kg is the mass of the pistol and 0.02 kg is the mass of the bullet. 0 represents the initial velocities U1 and U2 of both the bullet and the pistol before firing. That is equal to 0 kg meters per second. Now we will find the total momenta of the pistol and the bullet after the firing. Here also we use the formula for momentum, mass into velocity. This equals 0.02 kg into plus 150 meters per second plus 2 kg into V meters per second. Here 0.02 kg is the mass of the bullet plus 150 meters per second is the velocity of the bullet, 2 kg is the mass of the pistol and V is its velocity after firing. That gives us 3 plus 2V kg meters per second. According to the law of conservation of momentum, total momenta after the firing equals the total momenta before the firing. This implies 3 plus 2v equal to 0. That means 3 equal to minus 2v. This implies v equal to minus 3 by 2, that equals minus 1.5 meters per second. Here, the negative sign indicates that the direction in which the pistol would recoil is opposite to that of bullet, that is, from right to the left. Example 9.7. A girl of mass 40 kg jumps with a horizontal velocity of 5 meter per second onto a stationary cart with frictionless wheels. The mass of the cart is 3 kgs. What is her velocity as the cart starts moving? Assume that there is no external unbalanced force working in the horizontal direction. First of all, given here are mass of the girl is 40 kgs, velocity of the girl is 5 meters per second, mass of the cart is given as 3 kg, and we know momentum P equal to mass into velocity. Let V be the velocity of the girl on the cart as the cart starts moving. Now here in this picture, we find in figure a girl of mass 40 kg jumping with a velocity of 5 meters per second. The mass of the cart here is 3 kg, but the velocity of the cart is 0 meters per second as the cart is not moving. In figure B, we find the total mass after jumping is 40 plus 3, that is equal to 43 kgs. And we need to find out the velocity v with which the girl is moving on the cart. First, we will find out the total momenta of the girl and cart before the interaction. That is, before the girl jumps onto the cart. Here we use the formula for momentum equal to mass into velocity. That equals 40 kg into 5 meters per second plus 3 kg into 0 meters per second, where 40 kg and 5 meter per second are the mass and velocity of the girl and 3 kg and 0 meters per second are the mass and velocity of the cart that is at rest. So we get 200 kg meters per second. Next we will find the total momentum after the interaction. That is, after the girl jumps onto the cart. Here also we use the formula for momentum equal to mass into velocity. That is 40 plus 3 kgs into v meters per second. That equals 43 v kg meters per second, where 43 is the total mass of the girl and the cart together and v is the velocity of the girl on the cart. According to the law of conservation of momentum, the total momentum is conserved during the interaction. Here conserved means constant. That means the total momenta before and after the jump are the same. That is 43v equal to 200. This implies v equal to 200 by 43. That is equal to plus 4.65 meters per second. Here the positive sign shows that the girl on cart would move with a velocity of 4.65 meters per second in the direction in which the girl jumped. Example 9.8. Two hockey players of opposite teams, while trying to hit a hockey ball on the ground, collide and immediately become entangled. One has a mass of 60 kg and was moving with a velocity of 5.0 meters per second, while the other has a mass of 55 kg and was moving faster with a velocity 6.0 meters per second towards the first player. In which direction and with what velocity will they move after they become entangled? Assume that the frictional force acting between the feet of the two players and the ground is negligible. Now here in figure A, we find the two hockey players running towards each other in opposite directions before the collision. Figure B shows the scene after the two players collide with each other. Now the total mass is 115 kgs and their velocity after collision is v meters per second. Here, first, let us understand what is the meaning of the word entangled. Entangled means collision of the two players. For the solution, given here are the mass of the first player equal to 60 kgs, velocity of the first player equal to 5.0 meters per second, mass of the second player is 55 kgs, velocity of the second player is 6.0 meters per second. First, let us find out the total momenta of the players before collision. For this, we use the formula for momentum equal to mass into velocity. That is 60 kg into 5.0 meters per second plus 55 kg into minus 6.0 meters per second, where 60 kg and 5.0 meters per second are the mass and velocity of the first player, whereas 55 kgs and minus 6.0 meters per second are the mass and velocity of the second player. Here, note that the velocity is shown negative because the second player is coming in the direction opposite to the first player. So we get 300 kg meters per second minus 330 kg meters per second. And this equals minus 30 kg meters per second. Let the velocity of both the players after the collision equal to v. Then the total momenta after the collision is given by m1 plus m2 into v, that is equal to 60 plus 55 kgs into v meters per second. And this equals 115 into v kg meters per second. According to the law of conservation of momentum, total momenta before collision is equal to total momenta after the collision. This implies minus 30 kg meters per second equal to 115 into v kg meters per second. This gives us v equal to minus 30 upon 115. That is equal to minus 0.26 meters per second. Thus, the two entangled players would move with a velocity of 0.26 meters per second from right to left, that is, in the direction of the second player was moving before the collision. That's all for today. Thank you.